All right, so now we're going to do another lab. This lab is about graphing. So as promised, we're going to look at how the graphs are related of f, f prime, and f double prime. So this is the lab that says graphing lab that is attached to today's videos. So once again, I'd like you to download this lab first and do it on your own, and then check back with the videos and see if you got it right. Okay, so now I'm assuming that you have completed the lab on your own, and you want to check to see how you did. Or if you were stuck, will get you unstuck. All right, so what's f prime using the power rule? It's 3x squared minus 1. I'm missing the minus 1 on my Desmos. There we go. And what is f double prime? So the constant goes away and we just have 6x. All right, so those are our derivatives. Now, it says to use Desmos this time because Desmos is just so wonderful. You should download Desmos on your phone or use it on your computer or on your iPad. And then get a window of -2 to 2 by -2 to 2. So of all three of these. So here they are. All right, here's f is red, f prime is blue, f double prime is black. Here they are all listed out here. So the reason that it's really nice to have Desmos on your phone or your tablet is you can like zoom the x and y axes independently, which is just a really useful feature. So this is a good way to view it. All right, so you could also use your graphing calculator for this. I just thought we'd be able to see nice pictures here. We'd like to see nice pictures in full color, so I want to take advantage of Desmos. All right, so now we're asked things like, what is the interval where f is increasing? So f is the red graph, is increasing along this branch, but here f is decreasing, and then here f is increasing. So we're increasing from -infinity all the way up to whatever this x coordinate is, the x coordinate. So everything we're doing is in terms of x coordinates. So of course, another nice thing about Desmos, I can just tap it and it tells me that that maximum is -0.577. So now I know that the increasing part is -infinity to -0.577. And then then the other maximum is positive 0.577. So that's how we knew that the increasing intervals were -infinity to -0.577 and 0.577 to infinity. Now where's f prime positive? So f prime is the blue graph, right? F prime is the blue graph. So positive means it's above the x-axis. So f prime positive means from here to here. All right, we want to know what are those x values that end here. All right, so we can tap that and find out what this x-intercept is. Hey, it's also -0.577. So that means that this graph is positive from negative infinity, right, really, from x equals -infinity to x equals -0.577. That's where f prime is positive. F prime is negative, that is below the x-axis, from -0.577 to whatever that point is. I wonder if it's positive 0.577. It is. It's positive 0.577. All right, so the graph of f prime. So you can't just say the graph is this, the graph is that anymore. So here's the graph of what? The graph of f is negative from -infinity to -1. But the graph of f prime is positive from -infinity to -0.577. The graph of f prime is positive from 0.577 to infinity. Okay, so f prime is positive from -infinity to -0.577 and 0.577 to infinity. Hey, that's the same interval. All right, how about where f is decreasing? So f, remember, is the red graph. So where's f decreasing? F is decreasing from x equals, remember we're doing only x coordinates here, x equals 0.577, -0.577, and then here's f decreasing down to positive 0.577. All right, so f is decreasing on the interval -0.577 to positive 0.577. Okay, whereas f prime negative, f prime is the blue graph, whereas the blue graph below the x-axis from -0.577 to positive 0.577. All right, so you're sort of hopefully getting a sense of how the f prime and f are related, right? F prime and f look like very different graphs, but wherever f prime is positive, f is increasing. Wherever f prime is negative, f is decreasing. Wherever f prime is positive, f is increasing. All right? Okay. Now, we have this one filled in. F has a max at our favorite number, so there's the max right there. It's negative 0.577. We only want x equals negative 0.577. All right, where does x have a min? That's centered there. Where does x have a min? All right, f have a min. So here's my red graph f. The min of f is, of course, at x equals 0.577. So we'll say x equals 0.577. Okay, where is f prime equal to 0? All right, now f prime is equal to 0 at 2 points. At negative 0.577, remember f prime is a blue graph, and f prime is 0 at positive 0.577. All right, so we can say f prime is 0 at x equals negative 0.577 and x equals positive 0.577. There were 2 points. So f prime is 0 at the point where there was a max and at the point where there was a min. So I wonder how you'd know which one is which if you knew f prime was 0. All right, so when does f prime change from positive to negative? So f prime is the blue graph. Where does f prime change from positive to negative? Right here. Now look at this intercept over here. F prime is negative, and then it changes to positive. Remember, we're always talking about increasing x when we talk about that. So f prime is changing from negative to positive at 0.577. F prime is changing from positive to negative at negative 0.577. All right, so x prime changes from positive to negative at x equals negative 0.577. Hey, that was the max, huh? And then f prime changes from negative to positive at x equals positive 0.577. And hey, that was the min. I'll be darned. All right. Where's f concave up? Okay, so if you forgot, concave up holds water like a cup. F concave down like you're wearing a frown. Concave up holds water like a cup. Concave down like you're wearing a frown. That's my thing. I invented that. All right. So where is f concave up? Well, f is concave up. Well, it's hard to tell exactly where it changes, but I think it looks like it's concave up, right, along from 0 to infinity. From 0 to infinity. All right, so f is concave up on 0 to infinity. All right, where is f double prime positive? Where f double prime is the black line. Where's the black line above the x-axis? Oh, from 0 to infinity. Where is f concave down? Okay, so f concave down like we're wearing a frown, right around this curve and down to here. All right, so it looks like negative infinity to 0. Negative infinity to 0. And where is f double prime negative? Here's f double prime is the black line. F double prime is negative. Looks like all the way over here, so negative infinity to 0. Negative infinity to 0. Oh, how about that? What are the degrees of f, f prime, and f? Well, here's f, it's third degree. Here's f prime, it's second degree. Here's f, it's first degree. Now, you can see that really clearly in the graph, right? Cubic, quadratic, linear. F, f prime, f double prime. Now, you could have started with like a quintic or something, and then it would be a quintic, a quartic, and a cubic, like that. That's right. But so now we've observed some of the early relationships, okay? I'm not going to help you with this side. You got to do this side on your own. This is going to count for homework. And so the next thing we're going to do, if you haven't done it already, is fill out these conjectures, which we've kind of already alluded to.